Institute
This
of
conference will now be recorded.
I'm sorry. So yeah, we have Dr. Iman El-Wazan from the National Institute of Oceanography and Fisheries, Egypt. So yeah. Dr. Iman, yeah. Your voice is actually not audible, doctor. It's on mute.
Okay.
Yeah, now it's
Can you
audible.
hear me now?
Yeah.
Okay. Good morning. I'm Dr. Iman El-Wazan from Egypt. I'm Associate Professor of Invertebrate Aquaculture. My specialty is bivalve aquaculture. Our subject today is bivalve aquaculture in Egypt, opportunities and the challenges. First, I will give you very brief information about Egypt. Egypt is a transcontinental country located between have the main land in Africa, and the part of it, which is Sinai, is located in Asia. Aquaculture in Egypt started since ancient times. We found, like they found some drawing in the temples dated back to 2500 BC. Egyptian practiced aquaculture for over 2000 years. Egypt is the top country in Africa regarding aquaculture. 71% of total aquaculture production in Africa, according to FAO organization. 99% of production of Africa. Aquaculture in Egypt is the main source of fish and fish resources, but marine aquaculture is not developed as freshwater and brackish-water aquaculture. However, as you see in the chart, there is no reported mollusk aquaculture in Egypt. The cultured species in Egypt are mainly carp and tilapia, and the brackish water species are shown here in addition to shrimp. However, no bivalve or mollusk aquaculture reported in Egypt. Of course, we know the commercial importance of bivalves. They are used for food, jewelry, and ornamentation, for medical product, many uses. The top world bivalve producers are mainly in Asia, followed by Europe. However, in Africa, the production is very low, and in Egypt, it's absent completely. Mollusks in Egypt are found in the Mediterranean coast, Red Sea coast, and the Gulf of Suez. And Egypt have many mollusks, either exotic or native species. Bivalve species in cultured worldwide are mainly mussels, scallops, and clams and oysters. And we have in Egypt many of the commercial bivalves are seen in the lower pictures. We have clams and oysters are mainly used and known to the market. So what are the opportunities if we start aquaculture, bivalve aquaculture in Egypt? Bivalves are promising candidates for aquaculture because Egyptians know bivalves more than other mollusks. They are increasing consumer demand because we have the problem of depleted fisheries or contaminated fisheries. And of course, aquaculture will be alternative if we culture the bivalves in clean areas. So why culture bivalve in Egypt? We have many good things that we have increasing demand on this, especially in these bivalves, especially in tourist areas. And also fishermen claim that the fisheries are declining, and some of them go out of business because of that. So there is need to develop bivalve aquaculture in Egypt for fish restoration or for use instead of exhausting the current fisheries. Egypt also have extended water resources. We have the Mediterranean Sea and the Red Sea coast are extend about 2,000 kilometers. We have inland fisheries like the northern lakes, like Lake Mariot and Etko and other lakes on the Mediterranean coast. And also we have inland waters. Also, the fisheries of bivalves, the commercially important bivalves, are distributed all over the Egyptian coast in the Mediterranean, Suez Canal, and Red Sea. Mainly 6 cities have the main fisheries. Also, bivalve aquaculture might provide fixing of the problems that the aquaculture sector in Egypt is facing. Like we have like a small number of bivalve farms, but they suffer from uncontinuous seed supply due to mass mortality, overfishing, or pollution. And also they suffer from transfer of disease from fisheries to the farm. And of course, of aquaculture, if we have pathogen-free seeds, it will help these problems. Also, marine fish farms have high fish mortality. Sea level rise make problems, expensive water quality treatment, and high price of fish feed. And also restaurant and fish stores suffer from buying the imported bivalves at high prices due to the more demand than the available in the fisheries. So bivalve aquaculture will be a fixing of these for these problems by providing year-round supply of quality seeds, and also it improve water quality because they are filter feeders, and no treatment needed for improving water quality. Also, it will cover the market at low prices. We have here, we had market study, and we try to like calculate the profit from fish aquaculture, marine fish aquaculture versus bivalve aquaculture. We found that the clam aquaculture cost less and have more profit. Like the net profit for fish from 3.5 faddan is about 70,000 Egyptian pound. But the corresponding bivalve for the same area is almost 2 million Egyptian pounds. The opportunities of bivalve aquaculture in Egypt are great because marine aquaculture is encouraged by the government. The technology transfer will drive development for this industry. Also, bivalve is the most extensively studied groups in Egypt, and also they have established and developed confirmed standard mariculture techniques. Also, large number of current bivalves fishers, they suffer from unemployment, and we have from this sector, we have many people that can work in this field if we establish the aquaculture in Egypt. A large number and the area of marine farms in Egypt. We have about 74,000 faddan of marine farms, and this can transfer part of their farms into bivalve aquaculture. Also, aquaculture will cover the local market shortage, and it will improve the livelihood of unemployed fishers. The transfer also, the availability of Egyptian scientists trained on bivalve aquaculture. Myself, I had my PhD from America in bivalve aquaculture, and I trained many students. We have a big team of bivalve aquaculturists now and scientists. This is like the transfer of technology from America to Egypt. we started the grow out in Egypt. We had 3 projects. I worked on 3 projects, and the first project studied the rodi-tipped cossatus clam. It was US Egypt project. And we studied the reproductive biology, microbial studies, histopathology, many studies from this project. Other project with FAO and ESTMED, we studied the resources of bivalves in Egypt, and we try to transfer the hatchery practices to Egypt. And these are my students trying to spawn the clams. Many researchers have been published from these projects. The other project was market study of the hatchery produced bivalve seeds. In summary, we found that we have 1,344 farms at area of 74 faddan in Egypt, and this will be our prospective customers in case hatchery-based bivalve aquaculture is established. These are our customers, and we try to calculate the addressable market for bivalve seeds, and we found it's about 5.6 billion Egyptian pound in total. For seed supply of 5% only of the existing farms, the profit will be 277 million Egyptian pound per year, which is good. The second product, which is the grow out, the market size bivalve, we didn't calculate it yet, but it's a big market when we provide the clams for the households and the markets and export. And this market is not like the research is ongoing to calculate this market, the market size clam or bivalves. The opportunities in food industry, bivalve comprise great candidate for food industry because if we establish the bivalve aquaculture in Egypt, we will need at least processing and the cleaning and the depuration and sorting of bivalves, and this will provide employment opportunities and will be profitable kind of industry. Also bivalves are used in nutraceuticals and medicals and immune system enhancement. If the industry is established in Egypt, we'll have other studies based on it. Also, the challenges in aquaculture, like we have a great opportunity, but we have many challenges if we start bivalve aquaculture and we have to compete or fix it. Of course, these are journals of the problems of the marine aquaculture sector in Egypt. It's in Arabic, but I give it as example of the problems that might face us when we start bivalve aquaculture, and might deter or at least decrease the interest of potential investor. The social and the institutional constraints, like the lack of know-how of hatchery practices, lack of seeds, and the dependence of mollusk farmers on the seed, on the wild seeds, the possible limited demand on hatchery produced seeds. Like we say, okay, the farmers are suffering now from the shortage of seeds due to uncontinuous supply. However, if we establish the industry, but there is no enough farms to consume these seeds, it will be like bad for the investor himself. The difficulty to control and guard the bivalves deployed in coastal waters is another constraint, because we, like most of the fish farms in Egypt are inland, not coastal farms. Also, the biological constraints are the absence of mollusk hatcheries and the lack of high-quality pathogen-free seeds, because we don't have yet hatcheries in Egypt. The lack of shellfish health control system, because we don't have experience in that kind of aquaculture, might be another constraint. And this may make the export of produced bivalves not possible, especially to Europe, because Europe have very strict rules about bivalve shellfish safety. The environmental constraints like the deterioration of water quality, outbreak of red tides, and accumulation of toxins. We can't control that. And the global warming affecting the weather and may comprise danger to the deployed bivalves. And also it might affect the bivalves with calcareous shells. The financial constraints are the biggest issue in Egypt, especially during the market study. We found very like they doubt about the industry, and if they will, like most of the investors that we met with them, they said, oh, I can't guarantee that I will have my customer. And especially with the big capital of establishing a bivalve hatchery, the difficulty of funding agencies for new industry like shellfish with no proven feasibility under Egypt conditions. Also, the competition from the fishery produced seeds is another issue, because of course the fishermen sell seeds at low cost, but of course they don't have as quality seeds as it would be produced if it's produced from the hatchery. The constraints in food industry, mollusks, especially bivalve, are filter feeders and can bioaccumulate contaminants, and this makes them unedible in if cultured in unclean places. And the spoilage and the deterioration of shellfish of bivalve product, these are very big constraints, especially with no experience in Egypt in this market. The governmental constraints are a big issue in Egypt because of lack of rules and regulations for bivalve fishing and the aquaculture sector, no licensing for bivalve farms or workers like we do with fish aquaculture, because fish aquaculture is very established in Egypt since ancient times, but this is still new technology, and we don't have any rules for it. Lack of announced plans for using capital to support startups of bivalve aquaculture is another constraint. The national security concern that might lead to prohibition of use of coastal areas, because like the coastal areas are critical areas for the Egyptian government, and we think we will have problem of renting or opening like sea farms in many areas of the countries. The most important constraints for Egypt are the lack of know-how, the lack of public awareness of the importance of bivalve as food for consumers and the profitability for investors, the possible low demand on hatchery-produced seeds at the beginning of the emerging industry due to limited number of farms in Egypt, which can be satisfied from natural fisheries in case the quality of seeds is not a priority for the farmer. The conclusions are that the future for the hatchery-based bivalve production in Egypt is bright, since they are already accepted by consumers in the Egyptian market and have confirmed potential customer locally. Local demand exceed supply, especially in tourist area, hotels, restaurants that currently consume imported bivalve to cover the shortage of market-sized bivalves. Also, there is a considerable export market in case biosecurity practices and the regulations are strictly applied, and which we have project to do that in the next 2 years. Stakeholders from the government and investors should help start this new hatchery and expand the industry. The biosecurity measures must be applied to bivalves, and depuration is a must before distribution to the consumer or the food industry. I would like to thank all the funding agencies and the countries that supported these projects. Like I have worked on 5 projects supported by these organizations. And this is the end, and thank you. If you have any questions.
So if there are any questions, please do come forward.
Okay.
So yeah, thanks a lot for your
Hello,
presentation.
Jessica.
Yes, yes, Dr. Wilson.
Uh, yeah, can I have one questions, please?
Sure, sure. Please.
Hello.
Hello. Yes, I
Yeah.
hear you.
Good. Yeah. Good morning, everyone. Thank you for Dr. Eman El Wasan very good presentation. I have one questions. Do you have giant clam sculpture there in your place? Because we have planned to culture and induce spawning of giant clams, because giant clams in my place are really under big exploitation. So we have planned to conserve them and bring back their population in the wild. So if you have program related to giant clams, maybe you can share with me how to develop them and how to bring back their population in certain areas. Thank you.
We do have Tridacna, a giant clam in the Red Sea, and it's endangered in the Red Sea too. I submitted proposal for culturing giant clams like 5 years ago, but it wasn't accepted. But I know that there is a project called HEPCA in Marsa Alam. I'll share with you the name of the organization and the place. They do giant clam aquaculture for restoration in a city called Marsa Alam in the south of the Red Sea. You can provide me your email, and I will give you the link for the organization. Maybe you can contact the PI of the project. Is that okay?
Yeah, thank you. Yeah, thank you.
Yes,
Thank
we
you.
do have it, and they export from it too. They export seeds of giant clams for aquarium trade. But it's not with me. It's not my project because I didn't start it. But I can I can connect you to these organizations.
Okay, thank you. Thank you very much.
Thank you.
So do we have any other questions? So I guess there are no questions anymore. So yeah, thanks a
Okay,
lot,
thanks.
Dr. Iman. It was really good to have your presentation.
Thank you.
Thanks a lot. So yeah, as we have missed out the presentation from Dr. Wilson L. Sira from Universitas Kristen Artha Vakana, Indonesia. So we have him right now available. So yeah.
So again, I'm sorry.
Mhm.
Did Mr. Rishi, who was asking about the giant clam, can you send me on the chat
Okay.
your email and send you?
Dr. Wilson, could you please share your email in this chat so that Dr. Eman will
No,
send you?
I am saying about the doctor who was asking about the giant clam.
Yeah, it was actually Dr. Wilson who was asking you about that.
Oh yeah, okay. I got confused. Okay.
That's
Yes,
okay.
please, Dr. Wilson, share it with me, and I'll send you email. Thank you.
Dr. Wilson, your voice is not audible to us. I'm sorry.
Yeah.
It's actually still not audible. Like, oh, I'm sorry, doctor, to interrupt you, but your voice is actually not audible.
Okay. Yeah. Thank you.
Yeah.
Yeah. Hello. Good morning, everyone.
Hi. Yeah.
Hello.
Yeah, your
Hear
voice is
noise,
now
Jessica.
audible, doctor. Yeah, I can hear you.
Hello. Please, hello. Can you hear me, Jessica?
Yeah, now I can hear you.
Hello.
I can hear you. Like,
Okay.
yeah. I
Okay.
have
Can
made
I
you the
now
presenter.
share my presentation?
Sure. Yeah. Please click on the screen button to share your presentation with us. Nitar-
Yeah.
Uh, Dr. Wilson, you can just click on the slide button just beside the 70%.
Yeah.
Like,
It's.
uh,
I'm sorry. It's for a while. For a while. Yeah.
Mhm.
Okay,
Yeah, it's visible. It's perfect.
okay. Can I start now?
Yeah, yes, doctor, you can start.
Okay, yeah. Good morning, everyone. I'm Wilson Tissera. Yeah, I'm Wilson L. Tissera from Artawacana Christian University, located in Kupang City, East Nusa Tenggara Province, Indonesia. Now I'm presenting to you our paper entitled Control of Ice Disease and Growth in Farming Red Algae Capophycus alvaraceae through the application of diversification method. My co-author is Doni Mbesi, then Ambarianto from Diponegoro University, Catherine Paulus from Nusa Cendana University, and Johannes Nian.
Dr. Wilson, I'm really sorry to interrupt, but I'm not sure if you have paused or you're still talking, but your voice is not audible to us. Yeah, your voice is actually not audible. Oh, Dr. Wilson is offline.
Yeah, maybe something problem with his internet
Network.
connection. Yeah,
Okay.
used to be like that. But I will text him to ask about this
Okay,
problem because
sure. Sure, thank you.
Hello, Jessica. Can we know what is happening, please?
I'm sorry for the inconvenience. Like I was trying to contact Dr. Wilson Serra and he's having his internet connection, like the disruptions in internet connection, and yeah, he's trying to solve that out. And even Dr. Alfred is being in contact with him, and yeah, we're just trying to figure out.
Okay, thank you.
Yeah.
Hello, Jessica.
Yes, Dr. Alfred.
Dr. Wilson have a problem with the connection, internet connection, so he is asking me, is it okay for you, everybody, to wait for a while so he can reload again?
Okay, then in this case, like, shall we just move on with the next session so that in the meantime, Dr. Wilson can set his internet? Is that
Okay, okay.
fine?
Okay. Yeah, I will talk to him.
Thanks a lot. So, yeah. So, due to the problem with the connectivity, we'll just move on to our next sessions. Moving on to our next sessions, we couldn't try it like Dr. Shailesh Gadhvi from India is not available due to some personal issues in his he might not attend, and the speakers from USA and Brazil, it's really not easy for them to attend right now, so we'll just wait till the end of this webinar. And even then, because it's like it's 6:12 a.m. here, so I guess it's not that easy to call up and disturb them at this time. So we just felt we'll just transfer the session to the last. And yeah, to the next session, we have Dr. Vincent Asogwa from University of Eswatini, the Kingdom of Eswatini. So, Dr. Vincent, are we ready for the presentation? Dr. Vincent, is there anything I can help you out with? I'm sorry, your voice is actually not audible to us. I could see you talking, but your voice is not audible. I'm sorry. The internet. Oh, yeah.
Yes, all right.
Choose. Look there. There's no need for you to enter into that. Like your screen is already being shared with us, so no problem. You can just minimize that, maybe.
I think he can't hear us.
Oh yeah, but there is nothing to do with logmein support.
Please try to send him a message.
Okay, one moment. Dr. Vincent, can you hear us? Okay, you can hear us, but I'm not sure. I do not know why I'm not able to hear you. Okay, just
Yeah.
are you connected
Okay.
to any head doctor, are you connected to any headphones? Could you please check if you're connected to any headphones? Or you can just remove all your headphones and just use the laptop voice, like the speaker. Okay, try using the settings in the laptop just beside on the top right corner. Just go with the settings and you'll be able to see the computer audio is on or off. Just check if the microphone and speaker is of the same that you're using. Still not able to hear you. I'm sorry. Oh, could you please send us a message over there in the chat box so that we'll just see what's your problem? Like, we couldn't understand to help you. I'm sorry.
Yes, Dr. Vincent. We can't hear you. Your voice is not audible. Yes, you need to go to the setting and give the access to the software GoToMeeting. Or maybe you are facing some hardware problems.
Oh, yeah. Could you please check if the setting, camera and audio settings at the right corner, you have everything working properly? You'll have a green color box stating the computer audio is on. So if that is connected, then your voice will be audible to us. Oh my God, it's not audible.
Or maybe someone can share his screen and show him.
I'll just see if I can do that. Okay, in the meantime, I'll just call and talk to Dr. Wilson. So in the meantime, we'll just move forward. Uh, Dr. Wilson, are you ready with the presentation? Like, is your network connectivity proper or you still need time?
Uh, Hello, Jessica.
Yeah. Yes, Dr. Wilson.
Yeah, okay, I try now.
Okay, thank you. One second. Yeah. Please connect to share your screen.
Yeah,
Dr. Wilson, yeah,
okay.
yeah. Now it's
Can
perfect.
okay. Uh,
Yeah.
Good morning, everyone. I'm Wilson Tissera from Artawacana Christian University, located in Kupang City, East Nusa Tenggara Province, Indonesia. I'm presenting to you my our study entitled Control of Ice Disease and Growth in Farming Red Algae Capophycus alvarezii through the application of diversification method. Yeah. Farming of Capophycus alvarezii has been done in Kupang district since 1999. Then people are farming Capophycus alvarezii because it is one of the main income for the region and farmers. So in this slide, you can see that at least there are four varieties being farmed in Kupang district. They are green sakol, brown kotoni, brown sakol, and tambalang. Yeah, this slide shows that seaweed production in Kupang district are really high every year. From this slide, you can see that every year since 2014 until 2018, seaweed production, especially came from Apophycus alvarezii, it's reached 1.3 to 1.5 million ton per year. So it's really main of the commodity in Kupang district. So then, since 2 decades ago, main problem arose. It called ice disease, and because of ice disease, the production decreases rapidly. So it's really bad dreams for the farmers and for the region. So in this picture, you can see that the plant with wide-scale whitening of ice disease. So therefore, the objective of this study, this experimental study, aim to minimize incidence of ice disease infestation in farming of Capophycus alvarezii to the application of diversification method. So for the method, this is the location of the study. Here you can see the map of Indonesian archipelago. Then East Nusa Tenggara province is here in red square. And this is Sulamu. It's our study site, study location in Sulamo, and we have 3 sites, 3 farming areas in Sulamo. Site 1, the red one, the site 2 in the yellow one, and site 3 in the green one. Then the study was conducted from July to September 2018. So this is seaweed that we do experimental study. The main seaweed was Capophycus alvarezii. Then we use also Gracilaria sp and Sargassum polycystum. This is experimental setup for the treatment. So for the treatment, we use 3 seaweed. The main one is Capophycus alvarezii. Then the second one is Gracilaria. Then the third one is Sargassum. So the view is like this. The main ropes is 30-meter long. Then we use three seed. The main one is Capapagus alvarezii, the green one here. Then the yellow one is Gracilaria sp. The red one is Sargassum polycystum. The distance between the main ropes was 1 meter. Then for the Capaficus and Sargassum, the distance between the seed was 25 centimeter, while for the Gracilaria was 20 centimeter. It was our treatment. Then for the control, as you can see in this slide, that for the control we only use Capaficus alvarezii. So the main ropes were 50-meter long. Then we only place Capaficus alvarezii without other seaweed. Then sampling were done every 10 days, and the data taken was growth, incidence of disease, intensity of disease, physical and chemical parameters of waters. Then for each site, we use 3 replicates. So for data analysis, for the growth, we use the formula according to Davis, Trono, and Luisman 1993. Then also we use also absolute growth. Then for disease infestation, we use formula according to Teixeira 2009. For incidence, number of infected bunches divided by total number of bunches times 100. Then for the degree of infection comes from number of infected branches divided by total number of branches times 100. For the result, this is the result of incidence of ice disease in Capaficus alvarezii farm for 50 days. The red line representative the control, and for treatment was the blue line. As you can see in this graph that both treatment and control infected by ice disease, and ice disease start from day 30 to day 40. So for the treatment, incident of ice range from 12% to 38%, with a mean of 14.4%. While the controls, it looks higher than the treatment. The incidence of ice disease in control, it ranges from 30 to 45%, with a mean of 22.2%. Then for the of infection of ice disease in Capophycus alvarezii farm for 50 days. As you can see in the graph that both infected by ice disease and the control show that degree of infection is higher than in the treatment. The control range from 10.58 to 49.67%, with a mean of 16.55%, while the treatment is lower, it ranges from 4.71 to 21.67, with the mean of 7.01%. So for the growth, this slide show the weight gain of Capophycus alvarezii for 50 days culture compared between treatment and control. The results show that for the growth, for the weight gain, the control show better weight gain compared to the treatment. The control reached 1078.6 in days 50, is higher than the treatment, only 1061.6 gram in days 50. So for the specific growth or for daily growth in percents, the results show that the control show better daily growth compared to the treatment. The control daily growth range from 1.3 to 9.7% per day, with the mean of 4.74%, while the treatment show lower daily growth with a range from 2.1 to 6.7, with a mean of 4.7%. Then for the absolute growth, if we compare between the treatment and control, the studies show that the control show better absolute growth, reach 978.6 gram, higher compared to the treatment 961.6 gram. Then we also collected physical and chemical parameters of seawater in farming location. Then we found that the temperature was 31.43 degrees Celsius. Salinity was 33.50 promille. Flow current was 0.26 meter per second, and the depth was 4.08. Light intensity 3.63 meters, pH 7.48, and nitrate 0.5 milligram per liters. And the physical and chemical parameters of water show the normal range, only normal value, only total was a little bit higher. Then for the conclusion, both control and treatment were infected by bacteria caused ice disease. And for the disease, the plant using diversification method show better resistance to ice disease compared to the control. Then for the growth, the plant using diversification method show lower growth rate compared to the control. That's all our study. Then we thank Kemenristek Dikti for research grant 2018 and seaweed farmer in Sulamo Subdistrict. Thank you for your attention.
Thanks a lot for your presentation, Dr. Wilson. So, yeah, do we have any questions for Dr. Wilson? So, do we have any questions? I guess there are no questions. Anyway, thank you for your presentation, Dr. Wilson. And
Okay, thank you.
thanks a lot. So, yeah, Dr. Wilson, can we just try once if the audio is now was audible or not? I have made you the presenter, so kindly please do check if there's anything. Could you please try and let us know at least through chat if you are talking or not? I'm not able to understand. So please do just send us a message. I'm sorry, doctor, your voice is still not audible to us. I'm really sorry. Like, I'm unable to understand like how I could help you out with this, but if this is the first time you're facing this. Mm. Yeah,
Uh, uh,
yeah,
can you can I suggest something?
yeah, please. Yeah, I was just reading your
Uh,
message.
yeah, 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 Dr. Wilson. When I tried my laptop, the audio wasn't working, so I joined from two devices. I was talking from my phone and sharing the screen from my laptop. Why don't you try to join from your phone? This way you can speak from your phone and move the slides from your laptop.
Hi, Jessica. I'm Dr. Salis Gadwi. Am I audible to you?
Yeah, yes, Dr. Shailesh. Yeah, you're audible.
May I know at what time my presentation actually gets start?
It was actually at 11 a.m. in London time, and we had to move on, like, as you were not available online. So, yeah, just give me a moment. We'll just figure that out. Like, once Dr. Vincent presentation is completed, then we'll just go on with yours. Is that okay with you?
Yeah, Jessica, it's quite okay with me. And I'm really very regretful that I joined late due to some network problem. Actually, I was
It's
not
okay.
able to join.
I completely understand. Like, yeah, today, like, we are facing this network issue from the beginning, so it's not a
Yeah,
problem. No problem.
yeah. So please bear me.
No problem. We'll just schedule it next, like after Dr. Vincent.
Okay, Jessica. Thank you, Jessica.
Okay, Dr. Vincent, let me inform you. The go-to meetings buttons, whichever is visible to you, will not be seen by us, and it'll be only displayed in your laptop. So you'll just have the three buttons present at the top. Just do click on that, and it'll just get shrinked off. I'm sorry, your voice is actually not audible. I'm really sorry for this. I don't understand like what's the problem, but even though it's not audible. Dr. Vincent, could you please try to download the app GoToMeetings from the Play Store or any other store so that you will be able to download the GoToMeetings and I will provide you the access code so that you will be able to talk from your mobile so you'll not have any issues with this. Okay, let me repeat it. It's I'm really sorry for making you all wait for this, but I just hope you understand the situation. Okay, maybe I think it's better we just move on to the next. Wait, we'll just. Okay, as Dr. Vincent has left the session, so yeah, we'll just move on with our next session. 1 second, I'm sorry. Um, Dr. Vincent, if you don't mind, could you please share your mobile number to me in this chat privately so that I'll just call you and explain you or anything I could help you. In the meantime, we can have our next scheduled talk. Okay, we'll just see. So we'll just move on with our next session by Dr. Shailesh from Sardar Patel University, India. So Dr. Shailesh, I hope you are online. And yeah, I'm just making you the presenter. So please do click on the screen button to share your
Okay.
screen with us.
Okay, Jessica, thank you.
Yeah, please do click on the screen button present at the bottom of your screen to share your screen with us. Yeah,
Yeah, Jessica,
yeah,
am I
I
audible
can.
to you?
Yes, you're audible.
Yeah, Jessica, I'm Dr. Speakers Delegates from India.
Mhm.
Are you able to view my screen?
Yeah, I can see your screen.
Okay.
Yeah.
Jessica, please hold up just a minute.
Yeah, sure.
Yeah, are you able to read the heading of my presentation? Water
Yeah,
pollution?
yeah. We can see it.
Yeah.
As you're using it through your phone, you can actually rotate the screen rotation, so it'll be clear.
Just a minute. Just a minute. I'm starting the screen rotator. Please just hold up.
Yeah.
For a few seconds, I'm stopping my screen sharing, and
Okay.
very soon I'm starting my screen sharing.
Okay.
Jessica, is it okay now?
Yeah, it's okay.
Yeah. So, as per India time, good evening to everyone, and as per London time, good afternoon to everyone. I am Dr. Speakers Delegates from India, Sardar Patel University. Presently, I am working with world second largest refinery, that is the Nayara Energy Limited, and we are very much concerned with the ocean because we are using waters from the ocean, and at the end of the process, we are dropping our water to the ocean. So I chose this topic because we have developed one new technique that will help to save our aquatic life, and many refineries are recommended to use such a technique, and it would be really very much beneficial to world if they are adopt this technique. So I'm starting my presentation, water pollution control in petroleum refinery to save aquatic life. Now, if we talk about, very first, let me give an introduction about ocean. Cover near about 71% of our Earth's surface. It's the major water sources for the entire world. It plays important role for a chemical and biological balance of the life and the earth. Friends, it's also a very rich source for the food. Not only that, it helps us for the transportation for a big vessels through ocean. We are getting crude from Gulf country to India, show ocean having a lot of contribution in our day-to-day life. But our human activity has created a lot of health, lot of trouble that has very harmful effect on the health of the ocean. And our ambitious industrialization and our harmful chemical wastage effluent has damaged marine life. In many mammal like fish and many others has a very drastic damages, especially whenever refinery creating any pollutant or any pesticides, polychlorinated biphenyls, and the range of other toxic pollutants that we are adding to the ocean, and it causes a very reproductive disorder for ocean life. Friends, major source of pollution for ocean is mainly water pollution and industries and waste disposal. All these are really very toxic to our ocean. Now, what are the major sources of pollution from refinery site? Refinery is basically engaged with the business of manufacturing motor spirit, diesel, liquid petroleum gas, and many other products like sulfur, asphaltene, naphtha, etc. Refinery usually on their own power plant also to run all these plants. Now, during this operation of power plant, many gaseous emissions and acids are there, and most of the refinery are on the coastal area, so directly affect to the ocean. Refinery also need a very high pressure steam for a different operation. The steam also generate a gaseous, and boiler house also create a carbon dioxide, carbon monoxide, and many gaseous harmful waste. We are having a cooling tower heat exchanger. We have also generating mostly aqueous waste through this system. Three waste, all these wastes are usually non-toxic. It's not that much powerful, but main raw material for refinery, that is oil. That oil is really very effective to ocean pollution, because oil may enter the seawater by number of ways, like cargo tankers washing at sea, by international discharge of oil waste during the tank washing, and many times some accidental spillage during the transportation of crude oil through sea transportation, by biology pumping up sea, import oil losses, collision in the port, tanker accident, and marine accident. Not only that, sometimes during the transportation of crude oil, some collision create fire, explosion, or grounding also, and grounding also. Resulting oil release in water. This oil leakage, sometime from pipeline also, to blowout of well disposal of drilling mud, oil waste from oil fields or refinery that is very near to coastal area, oil spillage mixed with urban sewage, because refinery not only the culprit for the ocean pollution, but sometimes of urban sewage and wastage, seeds, plastics, pesticides, and toxic compounds are preserving and complex the pollution problem in sea. Now, friends, let us see which are the major process through which some ocean pollution can create. So refinery main raw material is crude oil. We are doing the fractional distillation of this crude oil, and during this fractional distillation we are getting various products. During this, hello, am I audible to everyone? Am I audible to everyone? Jessica, am I audible to everyone?
Yes, I hear you. I can hear you.
Yeah. So may I continue, right?
You can continue.
Yeah. Okay. So refinery having a various product like naphtha, kerosene, aviation turbine oil, diesel oil, and some residual fuel. These are the major sources for the. These are the major energy sources for the entire world. Now, during the secondary process, we are getting a feedstock, lubricating oil, bitumen, coke, etc. So these were the brief introduction about our product through which some pollution creating and what it effect on our ocean that are how represented here through one very horrible picture, that is the collapsing coastal, and coastal is crying towards us. So water pollution occurs when energy and other materials are released in ocean. Friends, to save this ocean is our prime responsibility as a scientist. So here I'm going to, very soon I'm coming to the main point, my research work. Very first, let me clarify what is the marine pollution. You all are a very skilled person and you are very aware with the marine pollution. So I will not take much more time for the marine pollution. But simply I will say that it's the discharge of waste substance into the sea and resulting harm to living resources. Not only that, it also cause a very harmful effect to the human health and hinders to the some mammals in the ocean and some aquatic life. Marine pollution is associated with the changes in physical, chemical, and biological conditions of the seawater. Okay, friends. So now, just a minute. Yeah, just a minute. Now, we are taking the water from the sea. Ocean is the water provider to refinery. We are using this water for the major consumption of this water in our refinery process. That is for the cooling system, distillation, filter backwashing, and sometimes some ionization techniques, and vessel cleaning, equipment flushing. Surface water turnoff also generate additional volume of wastewater that need to be treated. Now, whatever water we are using in the refinery, before discharging it to the ocean, we are giving them treatment. Now, let me explain what kind of treatment we are giving. The major type of treatment that we are giving are physiochemical and primary treatment. Then, after primary treatment, we are going to the secondary treatment. And finally, if waters is not get clarified completely, in that case we are giving the tertiary treatment. Friends, refinery wastewater treatment are basically of two types. First is the oil removal. For this oil removal, we are using an American Petroleum Institute equivalent oil water separator that help us to separate two phases, aqueous phase and non-aqueous phase. In a non-aqueous phase, we are getting oil that floating over the aqueous phase. And in this way, we are separating it. In the next slide, we'll see the schematic diagram also. So it will help us to remove some confusion if you are having. This oil part is getting separated, and then we proceed for some treating some industrial wastewater by chemical and biological method. Now, physical treatment, chemical treatment, and biological treatment. These are the major three kinds of treatment that we are carrying out at our refinery, in our effluent treatment plant. Physical treatment, in which we are removing the dissolved and undissolved substance without changing their chemical structure. Means here we are not giving any chemical treatment to water as well as our waste material. Method used for this are very simple method. These are the physical method, cause filtration, flotation, and sedimentation. In second phase, we are giving some chemical treatment. These chemical treatments are based on some chemical reaction. In this way, in this treatment, we are changing the molecular structure. These treatments includes some major chemical reaction like oxidation, reduction, and precipitation. And third is the biological treatment. During these biological treatments, we are using some living organism to check is it this water is harmful to some aquatic life or not. And once we are assured that during the biological treatment our water is not so much harmful to aquatic life, then and only we are discharging this water to ocean. Now this is our schematic diagram of wastewater treatment. Friends, I don't know whether you are able to see it entirely or not, but I am describing it in a very brief. Initially, we are taking the inlet water, that is nothing but refinery used water. This water is undergo the neutralization process, and after neutralization, it gets settled for a certain hours, near about 5 hours. This is called the primary clarifier. And after primary clarifier is sent to the equalizer tank for near about 12 to 13 hours. And after equalization of this material, it goes to aeration tank. During this aeration tank, we are giving oxygen to this water in order to make it oxygen rich, because we know that to help it to some biological, it is very necessary to have oxygen in air. So after getting rich oxygen water, we are transferring it to the secondary clarifier. In the secondary clarifier, again we are giving it settling time, that is near about 7 to 8 hours. After this settling, we are transferring this water to one guard. This guard having two parts. One is the alum, that is the calcium oxide and calcium carbonate. Other is the lime, that is the slack lime calcium hydroxide. Once metal pass through this, it sent to the final clarifier. In this final clarifier, we are removing some solid sludge and waste, and then this treated effluent will discharge to ocean. Now here, these are the traditional way of treating the water, but some problems with this treatment is in the start of the treatment. Friends, in the starting of the schematic diagram, you may see the inlet, then the neutralization. This neutralization is not a very easy way. In our traditional way, and since last many decades, almost all refineries and process are using hydrochloric acid, sulfuric acid, and other some mineral acids for neutralization. Now these acids are very harmful, because our main purpose behind adding this acid to our wastewater is to minimize the pH of highly alkaline water. But the problem that creating during this pH control technique is that During this pH control, we are using mineral acid such as sulfuric hydrochloric acid that help us definitely to reduce the pH, but it all having some corrosive nature, and having a strong mineral acid lead to concern or potential harm to some aquatic animal. Because whatsoever care you are taking, even though sometimes some high concentration of acids are added to the discharge water, and it increases the acidic pH of water. Now here I have plot a schematic diagram for the wastewater just for the pH control. This is the system that I explained in the earlier diagram. It was explained as a neutralization process. This neutralization process are expanded from here. In this process, wastewater are sent to the oil separator, as I explained earlier, and American Petroleum Institute has given a special criteria for this oil separator. We are using that separator, and then oil and sludge are separated and aqueous phase are sent to the chemical treatment of emulsified oil. During this chemical treatment, as you can see in the bottom of the tank, HCl and L2SO4 twice, that is aluminum sulfate and hydrochloric acid, we are adding to the tank. These two are very harmful sometimes to the discharge water because it has no exit control. Whatever techniques you are using, whatever digitalization you are having, whatever accuracy and precision we are taking, even though sometimes higher concentration of HCl and aluminum sulfates are going with wastewater and it discharging to the ocean and causing a very harmful to aquatic life. Friends, so it is very essential how to remove this the effect of water. Now let us see what are the effect of water pH on fish and some other mammals on ocean. When pH of fresh water become highly alkaline, friends, it causes the damage to our surfaces of fish like gills, eyes, and skin. Not only that, it makes them unable to dispose of metabolic waste. High pH may also increase the toxicity of other substances. Now I'm going to describe about what are the harmful to aquatic life in this traditional method. Then we'll discuss some advanced technique. The most serious chronic effect of increased acidity in surface water appears is the interference with the fish reproductive cycle. So ultimately, it reduces the reproduction of fish and it causes a very challenge to measure food sources that we are getting from the ocean. Calcium level in the female fish may be lowered due to this high alkaline pH and to the point where she cannot produce eggs and fail to pass from various of fertilize the eggs and larvae develop abnormally. Friends, in addition to fish, there are many other effects of this acidic pH and alkaline pH on scallops. Scallops, coastal ocean acidification sets of a chain of chemical reaction that lower the ocean's pH, making it more acidic. Because during this discharge, we have added some mineral acids, and these acids can affect many marine organisms, especially those that build their cell from calcium. Being a scientist concerned with the aquatic life, you all are very much familiar that there are many mammals in ocean having their outer surface built with a calcium carbonate, such as scallops shown here. Friends, this is the real photographs that creating what a great damage to these innocent animals. Now let us see effect of water pH on fishes. I don't know, due to some very small writing. So are you able, if you are having laptop, you might be seen very clearly. But I'm describing you very briefly that we go to the maximum pH and its effect. So if pH is very high, then it could be hatched to the fish eggs and deform the youngs were often produced. If pH level is a mediocrity, means in between 9 to 8.7, then trout eggs and larvae develop very abnormally. Limits for perch, limits for stickback fish, tolerable range for most fish, upper limit for the good fish waters is the 8.7. Then at 11.4 pH, fish avoided waters beyond these limits. 7.2 pH is the optimum best range for the fish eggs, but hardly we are getting this pH because in our traditional way of treating a wastewater is not good to get the pH at 7.2. So this is the ideal pH, but hardly we are getting this. If we are able to create this pH, then it's best for fish eggs. Mosquito larvae were destroyed above this pH. 4.7 is very dangerous for the mosquito larvae that lived within this range. And if we go up to the 8.4 pH from 7.5 to 8.4, it is also again best range for the growth of algae. And as you know, algae is also a major food source for the aquatic animal. Now, these are the range of pH in which our aquatic organisms are very comfortable. If we talk about the some finger counted aquatic animals like snail, it has ideal pH is 6.0. Clams, it's again 6. Bass 5.5. Crayfish, mayfly, both are very comfortable within the pH of 5.5. Trout 5 pH. Salamanders is also a 5. Perch is 4.5 and frogs are near about 4. Friends, frogs, perch, clams are able to survive at lower side pH, that is in between 4 to 5. But and otherwise, most of the aquatic animals are very much comfortable and they can live a very healthy life between 5 to 6 pH, means very neutral pH, neither acidic nor basic. Now, here is the effect of pH on and warm bath, right? So if you are having a 4 pH, then it creates a acid death point. If your pH is 4 to 5, then there is no reproduction of our major foods that we are getting from the ocean. If pH is in between 4 to 6.5, then growth becomes very slow for all the fishes. If 6.5 to 9 pH, it is a desirable range for fish reproduction. If pH level is 9 to 10, then again its growth becomes very slow. So friends, in a very acidic pH, that is 4 to 6.5, and it's a very basic pH, that is 9 to 10.0, both pH are responsible for their slow growth. And if pH is going beyond 11, it's again a very dangerous, harmful and critical, because it's called a alkaline death point for aquatic animal. We have seen many times what a great harmful effect they create this wastewater. Friends, in the last few decades, a lot of fishes were damaged and get affected by this uncontrolled pH value. And this uncontrolled pH value is responsible for our traditional wastewater treatment technique, especially for the neutralization of water. Now, what is the new pH control technique? Friends, now new pH controlling technique is the very fantastic way of treating the water. What are the benefits and how it is very useful? Let me discuss. With the mineral acids commonly used in previous years, Now CO2 offers a main advantage. In this statement, we are using carbon dioxide. This best economical and ecological alternative. In this statement, we are using CO2 is not categorized as a substance that is not harmful to water and does not lead to the addition of unwanted anion in the water environment, such as chloride sulfate. Initially, in a traditional method, we were using HCl, that is hydrochloric acid. During this hydrochloric acid, we are getting the chloride, and during the sulfuric acid, we are getting sulfate, that are again to measure pollutant in water that we were discharging in the ocean, and causes a very harmful effect to the fish. There is also no over acidification of the wastewater. This is also the major benefit. Further, CO2 is the self-buffering, which produces a flat neutralization curves and no corrosion of the system, because mineral acids having a major loss of corrosion. Now, CO2 is also far safer than mineral acid because it is very simple to handle. Not only that, it can be delivered as a liquid cryogen that is stored in a tank, because it doesn't create any corrosion to the tank and dosed automatically in the process, so it's not a harmful to human also during its consumption. Now, here is the picture how we are using this. So injection of CO2 via CS nozzle producing bubble. Friends, here are the small animated photographs. In a left side, you can see two CO2 tower through which we are getting the CO2 gas into the pump, and here is the big tank that is of the wastewater. CO2 is continuously purging in a tank, and in this tank CO2 react with our basic material that is creating an alkaline pH of wastewater. The CO2 neutralize these basic residues, and the excess CO2 is again back to the tank, and this way we are not losing CO2 in the environment, but again it recycled and used. Now, what is the reaction of this new pH controlling technique? Friends, in this technique, we are using the CO2, our wastewater having a H2O. So this carbon dioxide and water both are reacting and giving us CO3 minus 2, that is the carbonate ion. This carbonate ion having an acidic effect, so it can neutralize our water. When this carbonate ion again react with water, it converts into the bicarbonate ion, and this consumption of bicarbonate ion impedes the calcification. This was a reaction. Now, what is the effective and safer environmental friendly solution? Friends, CO2 causes the formation of carbonic acid. This carbonic acid naturally adjusts the pH to a suitable level because it's a self buffer, so carbonic acid will not cross the pH either on the higher level or to the lower level. This treatment method is easy to control, as we discussed earlier, and byproduct it creates are very harmless. None of the CO2 is released into the environment, as I show you in the animated picture. Now, carbonic acid created in this process is a weak acid than sulfuric acid, the sulfuric acid we were using in our traditional method. And this means the pH of wastewater falls more slowly and is thus easier to control. Not only that, you can use CO2 gas safely, because even if you inject too much gas, the pH will not drop suddenly either on higher level or lower level below a certain value. In this way, sulfuric acid and other reagents are not required in this technique. Now, pH controlling technique, the fact that CO2 is a sequester and very effective to remove from the global. Friends, we know that carbon dioxide is again a very big challenge to the world. We are using here one pollutant to remove other pollutant. Our one pollutant was the alkaline pH or acidic pH that we are removing by other pollutant, that is the carbon dioxide. This carbon dioxide is again a very big enemy of the entire world, because this carbon dioxide is responsible for the greenhouse effect and global warming. If we are using it in such a good technique, it will help us to reduce the global warming. Therefore, less CO2 is being released into the atmosphere. So this is the major benefit of this new pH controlling technique. Friends, in this pH controlling technique, because of its natural buffer effect, CO2 will prevent influent pH dropping below 6. Even in case of overdose, and as CO2 is a weak acid, pH value drop more gradually than that we are using in a mineral acid like hydrochloric acid and other like sulfuric acid. This accurate control makes a very easy. It's also possible to optimally dose the polymer to maximize their operation. But most importantly, using CO2 is safer because nobody has to handle any corrosive acids. And friends, as you've seen in that animated picture, there is minimum manpower required for this operation. And this CO2 is also a byproduct for our refinery. So ultimately, we are using our byproduct, or you can say it's a waste product for removing the pollutant in wastewater. And this wastewater, when treated with this CO2 and carbonic acid, it helps us to control the pH of water that aquatic life prefer. So this beautiful harmful-less water, when added to the ocean, when discharged to the ocean, by maintaining the certain pH, it saves our aquatic life. And in this way, we can serve our industries, country, and global. Thanks to everyone for hearing me. Now, if you are having any question, please raise your question.
Thanks a lot for your presentation, Dr. Sailesh. It was really informative. So, yeah, do we have any questions? So, if there are any questions, please do ask. Oh. Okay, I guess there are no questions, Dr. Sailesh. Anyways, thanks a lot for your presentation.
Yeah, thank you, Jessica. Thank you for supports of your all.
Oh yeah, it's okay. Thank you. So moving on
Thank
to
you,
our
Jessica.
next. Thanks a lot, Doctor. So now moving on to our next presentation. Yeah, we'll move. We have Dr. Renato Silvano from Universidade Federal do Rio Grande, Brazil. One moment. Okay, Doctor, could you please click on the screen button to share your screen?
Oh, okay, I do that. Just a moment. Okay.
Sure.
Okay. Let's see. Can you see my screen now?
Yeah.
Okay. Let me try to. Just a moment. I'll try to put on the presentation mode so
Sure.
it will be easier for you to see the slides. Let me see if I can do that. Okay, can you see the presentation mode?
Yeah, it's perfect.
But can you see the full screen?
Yeah, whatever the screen, like the GoToMeeting applications present on your screen will be only visible to you. That will not be
Okay,
visible to us. Yeah.
okay,
So you'll have
but
3 dots. You can just click on
Excuse
that
me,
and you'll get.
the green thing on the
okay,
title, can you remove it?
okay. So can you see the full screen?
Yeah, but we
Oh,
have
okay,
a button.
Okay, but just let me see. Can you see the full screen, right? Because for me, it's I cannot see the side of the screen because of the layout of GoToMeeting. Could
Okay,
you see
just
everything?
click on the three buttons present at the top left corner of the GoToMeetings. So the GoToMeetings option will shrink. It'll just go off.
Okay, I don't know if I'm knowing how to do that. Okay, cool, excellent. Um, let's see.
And one
I
more
turn off
thing.
my camera
Yeah,
for a moment, so I
yeah,
think.
sure.
Okay,
Yeah,
so you can see the full screen, right?
yeah, it's perfect now.
Excellent, thank you. I am Renato Silvano. Thank you for the presentation. I'm from the Federal University of Rio Grande do Sul in Brazil, and I would like to talk about our work on effects of variables from local to regional scales on fish landings in tropical rivers. Okay, let's see. It's not advancing. I don't know why. Okay, cool. Yes, no. So most of the data I will show you are from this project that we made in the Brazilian Amazon, which was funded by the USAID from the US government. We also have this short video in this site, just in case you want to know more about our research there in the Amazon. It's if you log on to this, if you go to the site, you can see a short video. I should say that this work has already been published in Fisheries Research. So here's my contact, and you are free to write to me if you want to know more about that. Small-scale fisheries include the most of the fisheries conducted worldwide, and it's very important to provide food and income to many people. So this fisheries has a great socioeconomic importance. And the fisheries in the Amazon basin, which is this region showed here in the map of South America, they are mostly small scale. They have been not much studied and not monitored, and largely unreported also. Fish is the main animal protein consumed by riverine communities all over the Amazon, and we already have some signs of overexploitation of at least some large fish species. For example, the large arapaima, as you can see here in this photo on the left. Management strategies and some factors can influence small-scale fisheries at different scales. For example, at regional scale, we have some management decisions by governmental authorities, for example, protected areas and this kind of measures. And at the more local or communitarian level, we have decisions and responsibilities that may be shared with the community. Also, some local habitat characteristics can influence fisheries at this scale. And at the individual level, the fisheries can be influenced by fishers' behavior, the fishing technique they use, time they spend fishing, some socioeconomic characteristics of fishers, and their local ecological knowledge also. And some examples of these factors at the large scale. In a previous study, we observed that the average size of fish we sampled were positively related with distance, to urban center or distance to major cities. So each point here in the graph is a site, sampling site. Each symbol corresponds to one major Amazonian river. And what we see here is that fishes on average are larger when we go farther away from major cities. For example, the city of Santarém, which is located about here. Other factor that may influence at a regional and also at a local scale is the co-management system. So in the Brazilian Amazon, we have co-management systems, and these are basically protected areas, which include local people who can use natural resources there following some rules, including including through fisheries. And these protected areas are in the form of extractive reserves and also national forests, among others. And in our studied region, we have at least three of these protected areas, two extractive reserves, and one national forest. Also, in a previous study that we made in the Tocantins River here, also in the Brazilian Amazon, we studied 5 fishing communities distributed in 4 regions. And we can see here that the gray area corresponds to an extractive reserve. And here in this graph, we can see that these 2 communities, which are located within or close to the extractive reserve, these communities show it a higher catch per unit of effort of fish in their fisheries. So this previous study shows that these protected areas may influence fish catches. So considering all this, the goal of our study is to investigate the relative effects of variables related to different spatial scales on fishing yields, basically on biomass, catch per unit of effort, or CPUE, and fishing effort. And so we addressed the variables at regional scale, for example, river, season, protected area, and distance to urban center or cities. At more local scale, community, fishing community and habitat, and at individual scale. So some socioeconomic characteristics of fishers, and also some characteristics of fishers' behavior, for example, fishing technique, time spent fishing, or whether or not they sell the fish. We made interviews with fishers and monitored fish landings in 8 communities shown here in this map in the Negro River. And also we studied some communities in the Tapajós River, which I will show in a second. And here in the Negro River, 4 communities are located outside and 4 communities are located inside an extractive reserve, which is this hatchet area. In the Tapajós River, we studied 16 communities. 8 communities were studied in this project funded by USAID. Also, communities located inside and outside protected areas, plus some other communities which were studied in a previous project funded by CAPES, Brazilian funding agency. We used basically 2 methods. We made interview with fishers, and during interviews, we got these socioeconomic variables, and we also made a participatory monitoring of fish landings in this method, fishers voluntarily recorded their fish landings, their first 5 fish landings during each month, during a whole year. We provided this kit for fishers to record landings and some basic training to them, so they fill out forms, and we recovered these forms later on. And through this method, we got all these variables. So we got our 3, which are marked here in red, our 3 dependent or response variables: biomass of fish caught, fishing effort, and catch per unit of effort, and also all these explanatory or independent variables: fishing techniques, whether or not they sell the fish, whether or not they fish in groups, or if they fish in groups or alone, the habitat they exploit, lake, river, or igarapé, which would be a tributary or smaller river, time traveled to fishing spots, and the kind of boat they use. And we also got some general variables like season, the community where they recorded their fish landings, the kind of river, whether or not the community was located inside a protected area, and the distance from the community to the urban center or the major city in each river. So we could get more than 2,000 fish landings recorded by fishers, which we analyzed here. We applied mixed models. So as I said, our dependent variables were those 3: biomass, effort, and CPUE. And we analyzed all these independent variables and some covariables also. For these variables, we made some archaic comparison, so some model averaging approach to sort out those variables that influence the most the dependent variables. And for these variables, we also used other kind of modeling with a subset of the data. So here are the most important variables which influenced our 3 response variables. Basically, these ones: group fishing, fish sales, fishing technique, also protected area, distance to cities, and education. Here are the general results of the modeling approach. Here in these 3 graphs are the 3 dependent variables: biomass, effort, and catch per unit of effort. In the vertical axis, we have all the independent or explanatory variables. Basically, here are the mean coefficient value of these variables. Basically, when the coefficient value does not touch the 0 line, we consider that the variable was significant, and so those values to the right side, which are marked in green, indicate variables which were positively related to the dependent variables, and those that are in the left side, marked in red, indicated independent variables which were negatively related to the dependent variables. So I will explain in more detail some of these relationships that we found. For example, fishing techniques. Here are the fishing techniques we analyze it. So we spur fishing, long lines, which are several hooks attached to a line, angling or hand lines, cast nets, and gill nets. Gill nets are highlighted here because they were among the most used and most relevant fishing techniques. So here are the relationships of these fishing techniques with the 3 dependent variables we analyzed. GillNet was the most used fishing gear by fishers, and we can see that GillNet also were quite productive. So GillNet showed a high catch per unit of effort, and angling was also this was the second most used fishing technique, but this technique was not so productive, not so high catch per unit of effort. So maybe they use it because it's cheaper, and they also could be more selective. So this technique could be directed to catch some preferred fish. The cast net and spear fishing were less commonly used by fishers, but these techniques showed quite a high catch per unit of effort. So maybe they are not so much used because they would require more skill and more physical effort by fishers. It's important to mention here that we measured catch per unit of effort as biomass of fish, kilograms of fish caught, divided by hours spent fishing and number of fishers. Regarding fishing groups, we can see that fishing groups, uh, those fishers who go fishing groups got a higher biomass of fish and also employed more effort, but group fishing provided a lower catch per unit of effort, so group fishing was less productive to fishers. In fact, indeed, most of the times these fishers will go fishing alone, but sometimes they do go fishing groups, probably because this strengthens their relationship among them and also to improve security of fishing. We can see also that when fishers sell the fish, they got more biomass on average. They also employed more effort, and they also made a more efficient fishing, so they have a higher catch per unit of effort. It's interesting that even so, fish sale is occurring in about only 1/3 of fish landings that we sampled, and we still don't know whether fish sales would be a motivation of fishing or a byproduct of fishing. So when fishers got more fish, they sell part of the catch. But fish sales was much more frequent outside the protected area than inside, but probably because of some restrictions of protected area that forbidden fish sales. We observed an inverse relationship between education level and fishing effort. So those fishers with higher education level, they employed less fishing effort, and those fishers with lower education levels, they spent more time fishing. So these groups with lower education level could be at higher risk if, for example, fisheries are made more difficult or fish abundance is reduced by impacts, for example, large dams. And we also in Southeast Asia observed a similar pattern where fishers with higher education levels would be more prone to leave fisheries and do other activities. We also observed that fishers who have some other economic activities, for example, small-scale agriculture or extractivism, they employed less fishing effort. So, and most of these fishers have some other activities. So this may reduce their dependence on fishing resources. Regarding protected areas, we can see here that the biomass of fish catch or fish caught was higher outside than inside protected areas, but also the fishing effort was higher outside the protected areas. And considering the catch per unit of effort, in the Tapajós River, it was higher inside protected areas, which is here in gray, but in the Negro River was the opposite. The catch per unit of effort was higher outside the protected area. So we observed overall a higher fishing effort outside the protected areas, but regarding fishing productive or catch per unit of effort, we got mixed results. So in one river, it was higher within the protected area, and in the other river, it was even lower within protected area. And we also observed, as expected, a positive relationship between the productivity of fisheries or catch per unit of effort and the distance to urban center or major cities. So, for example, when you go further from the cities, you get higher CPUE, and this may be because near the cities we may have more habitat alteration like deforestation, and also because of large fishing boats like this in the picture. So these fishing boats usually came from large cities and go along the river fishing a lot. And we also observe a positive relationship between time traveled to fishing spot and the biomass, the total biomass of fish caught, and the effort, the time that fishers spend fishing. And this agrees with optimal foraging models or optimization theory. So according to this theory, fishers would try to optimize their catches. So if they spend more time traveling to fishing spots, they need to compensate that by catching more fish and also by employing more effort when they made the longer trips. So it seems that fishers there are trying to optimize their catches. So some general conclusions. Our results show that both large scale and small scale variables related, for example, to fishing techniques and fishers' behavior may influence fish catches. And this would be relevant to better understand the factors influencing fishing success and also to support management measures at different scales. For example, diversification of fishing activities seems to reduce fishing effort. So this will reduce both the impact of fishing and also the dependence of fishers on fishing resources. And also the protected area seems to have some effects to reduce fishing effort. And at least in one of the rivers, it improved also fishing efficiency. But this is important to mention because right now in Brazil, we have some difficult moments regarding the maintenance of these protected areas all over Amazon. And also these results could show some vulnerable groups, so some people that rely heavily on fisheries and may be vulnerable if fishing resources are impacted. So to finish, I would like to thank my co-authors on this paper, Friedrich, Gustavo, Franciele, and Luis. I also want for sure to thank the Fishers for all their collaboration with this study, the project funders, and thank you all for your attention. Thank you very much, and I'm open to questions now.
Thanks a lot for the presentation. It was really interesting and informative. So do we have any questions? Do we have any questions? Dr. Rashida Carey, like, do we have any questions?
No, no.
Oh, okay. Okay. So I guess there are no questions. Anyways, thanks a lot for your time.
You're
And for your
welcome.
early morning session. We are really sorry for the time difference and everything.
No, but that's not so bad. It's not so early here in Brazil, so that's
Yeah.
fine. Thank you.
Thank you. So moving on to our next presentation. So I would like to know if Dr. Vincent is available online, so that we can just check. Oh, Dr. Vincent, if you're available online and your mobile application is already being downloaded, please do let us know so that we can schedule your talk now. Okay, I guess he's not online. Dr. Vincent is not online. So yeah, moving on to our next presentation. We have Dr. Rashida Khari from Bharia University, Pakistan. So yeah,
Yes, I
Dr.
am here.
Yeah, you can,
Yes,
could you
I am
please,
here.
yeah, can you please click on the screen button to share your
Yeah, yeah.
screen with us? Yeah.
It's okay?
Yeah, it's visible.
Okay. Uh, no, but I'm not okay. Okay. Here
Okay.
I am.
Try clicking
My
on the
screen.
dots so that it'll get closed. The GoToMeetings buttons will get closed.
What?
The three buttons. I guess you're facing issue with the GoToMeeting pop-up.
I think some. May I?
Okay. Uh, at the top, at the top right corner or the left, sorry, the left corner, you will see the three dots. Please click on that so that it'll get closed. Left side corner. You'll
No,
have an arrow mark
no,
and
no.
three dots.
Someone else supposedly is doing. No. Hmm. Um, may I again join?
Yeah, sure.
It. I think it is some problem. Going to some problem, so I can join again.
Yeah, you can just click on the screen button
Oh,
and
okay.
once again click on screen so you'll get connected again.
Okay. Grandma can't tell you. राना वो स्क्रीन शेयर करनी है तो आई नहीं बात। अब वो ऐसा हो गया जब स्क्रीन शेयर कर रहा है तो पता नहीं कहाँ चीजें चली गई। इसे तो नहीं लगा कुछ। या इसमें तुम यहाँ यहाँ तो ये ये ऐसा हो जाए तो नहीं आ रहा है ना तो ये इधर से ये हटाओ ना मुझे नजर नहीं आ रहा ना। अब हेलो हाँ हेलो
Yeah, we
hello
can
yeah
hear you. We can
my
hear you.
voice is coming
Yeah, we can hear you.
and screen is coming or
Yeah,
not.
yeah, it's visible.
Okay thank you.
Mhm.
Now Bismillahirrahmanirrahim. Good morning. I am Professor Rashta Kali from Bahia University, Karachi, Pakistan. My topic is literature survey, shrimp farming in Pakistan. The shrimp fisheries has an important role in society to meet current and future food, livelihood, employment, business, and other economic needs. The capture fisheries is one of the largest food providing sector, whereas aquaculture has emerged as the fastest food contributing sector globally. This research determines the socio-economic structure of shrimp fisheries with a prime objective to expose an overview of shrimp fishery with economic perspective in Pakistan. Pakistan coast is about 1,000 kilometers long, extending from Indian border in the east to the Iranian border in the west. The exclusive economic zone of Pakistan is about 240,000 square kilometers, with additional continental shelf area of about 50,000 square kilometers. As such, the total maritime zone of Pakistan is over 30% of the land area. This region is characterized by distinctive oceanic phenomena that produce rich fisheries, minerals, and hydrocarbon resources. As far as Pakistan coastline is very long, but not too much wide, but it is rich with many flora and fauna because it gives suitable environment for many species to grow widely. Pakistan coastline support many muddy, sandy, and rocky beaches, linked estuaries supported brackish environment, delta, lagoons, bay, etc. Indus Delta is the most favorable breeding ground for many fish and shrimp species, exhibiting highly rich in natural resources. The stadium was the for sustainable development shrimp culture in Pakistan to propose developmental strategies for authorities to establish an extension aquaculture and fisheries department all over the country. and by promoting shrimp fisheries at coastal region to benefit and generate numerous opportunities for sustainable development in country livelihood. There are many species which are found commonly cultivated marine shrimps. Penis migrensis, जिसको हम बनाना Penis migrensis banana prawn, Penis indicus Indian prawn, Penis durum Atlantic pink shrimp, Penis azitex Atlantic brown shrimp, Penis sativarius Atlantic white shrimp, and Penis monodon black tiger prawn. These are the common cultured marine shrimps. If we talk about Asian countries, the two genera, Penis and Metapenis, which are belong to the family Peniidae, dozen species cultured, and Penis monodon and Penis japonicus and Penis mergensis, Indicus, Orientalis, and Metapenis. And these are the more dominant and important ones. Penis monodon, most common species found in southern Asian countries. Penis monodon, fastest growing species among shrimp, highly tolerating salinity. From freshwater to full strength seawater, salinity required 15 to 25 part per thousand optimum. Optimum temperature 26 to 30 degrees centigrade, cannot be tolerated below 21 degrees centigrade, and above 37 degrees centigrade, Penis indicus and Penis mergensis cultured to lesser extent in Asia. Both species required lower salinity, 5 to 40 part per thousand. About 27 species of Peniite shrimps have been reported from the coast of Pakistan. Among these, Penis, Metapenis, Parapenis, and Phaneropenis genera are found in the coastal seawater of Sindh and Balochistan. These shrimps, locally known as Kali, Kitty, Jera, and Zera. These species are also found in other coastal seawater of the world. Due to the demand of the shrimp and its excellent price, many countries made their practice, mostly Asian countries. Two species, Phaneropenis and Mergensis and Phaneropenis penicilliatus, are abundant in the shrimp catches of Pakistan in the northern Arabian Sea, but over the past decade, overfishing has caused tremendous stress on their stock, which is evident from the decline in shrimp catches despite the increase in the number of fishing trawlers. This decline can be alleviated by the development of shrimp farming in the country. The above mentioned two species, Parapenis mergensis and Parapenis penicillatus, are among the species cultivated in various parts of the world. Shrimp farming requires various components, and it is estimated that the fixed cost for beginning A shrimp farm is approximately 24 lakh and variable cost is around. The major marine harbors of Pakistan are Karachi Fish Harbour, Kawangi Fish Harbour, Pasni Fish Harbour, and Gwadar Fish Harbour, and Somiani Fish Harbour. There are about 29 fish processing plants with storage capacity of 10,000 tons, out of which 25 plants are located in Karachi near Ibrahim Headway. There were many attempts had been made in Pakistan to culture shrimp since 1980s, but due to several reasons, it was not succeeded. Recently, one project at Gharus Shrimp Farm running very expertly, giving 65 tons and 56 tons of shrimp in 2 years respectively. But they compelled to import the feed and post larvae from the Malaysia and Indonesia due to lack of expertise and hatcheries. For the aquaculture, pond site selection was an important process in aquaculture, as this can often decide the success or failure of the shrimp farm. During the phase of preference or should be given for gravity flow of water to facilitate easy pond grind and proper water exchange. A minimum elevation of 0.45 to 0.6 meter is essential to ensure proper drainage as grind of the pond bottom and proper water exchange. Generally, clay loam soil is preferred sand soil to avoid because of high water percolation. Soil with pH below 5 and high concentration of heavy metals should be avoided. Overall, there are 15 species of marine shrimps reported in Pakistan, with most of the commercially important species belonging to the kidney shrimps. However, from the period of 1971 to 2009, catch production of kidney shrimp accounted for nearly 45% of the total shrimp production. Other 29% catch production was registered for Talvi and rest 26 was produced by Jera catch. Jera is also one most important shrimp. Nevertheless, the 39 years data of catch of shrimp from 1971 to 2009 total to 409 tons. In addition, 247,265 tons from species of Jera and 279,941 tons by Kalli. And kidney shrimps productions were accounted at 439,203 tons. Altogether, average weight was calculated as 8,260 tons per year. This figure shows the progress of total fisheries production was more prominent with an increase to 19,707 million tons, including 16,914 million ton increase in capture and 27 to 2,793 million ton from aquaculture as compared to previous year 2014. Further, in 1991 to 2000, catch of shrimp was 283,291 tons, which was little higher than last 2 decades, and per year average was also little more at 9,443 tons, and the remaining duration of 9 years from 2001 to 2009 so quite low in production, as it accounted a total catch of 195,318 tons, with on an average 7,234 tons per year. Further, in 1991, these figures show the month-wise landing of all this figure shows the month-wise landing of all their shrimps species categories, that is kiddy, jera, and calvi. The highest landing of kiddy shrimp was recorded in September, October, and November. The production was decreased in the last year in the month of November. Moreover, production of jera shrimp increased in month of April, October, and November from 1971 to 2004. Additionally, catch production of Kalvi year-wise increase was recorded in the month of October, November, and December, respectively. This figure show represented the wholesale estimated average price of shrimp varieties at Karachi Fish Harbour Market. Fish Harbour Market, that is at Sindh and Balochistan coast from the period 2001 to 2009. In each season, month and year did not have the same market price. Even different provinces have different values. This is the variation in month and area. The export of cumulative frozen fisheries production from 1970 to 2009, that is the duration is about 40 years, was computed as 1 lakh 399,000 ton. The average was calculated as 34,009,075 ton per year, including 29.6 share of frozen shrimp in number, 4014 uh, 414,325 ton with average at 10,358 ton per year respectively. In addition, earning amount was 128,215 million Pakistani rupees, including 45.3% and that is 58,193 million Pak rupees share from frozen shrimp export. Above and this figure representing the statistical representation of growth, higher and lower export rate of frozen shrimp and other frozen fishery products. There are some issues in shrimp fisheries that these are environmental problem, coastal erosion, over exploitation of fisheries resources stock, improper awareness of fishing spot, improper licensing and issuing of fishing vessel to control natural fishery stock, improper abiding of fishing rules and regulation to control illegal gears and fishing methods. Uh, Besides this, there are some other issues that improper structured framework management of fisheries, lack of government and non-governmental institution joint effort management, non-appearance of mega plan infrastructure for community development, and inaccessibility of commercial chain shrimp producing hatcheries to facilitate local farmers, and non-attendance of marine aquaculture on local basis to give rise to seafood. Besides this, lack of local feed marketing industries to deliver low-cost feed for farming, and unavailability of aquaculture extension to transformation of awareness and technology adaptation. These are the issues and problems which are facing uh, shrimp farmers. The shrimp fishery in Pakistan play a significant role in terms of economic development, contribution in employment, nutrition, income generation, and foreign exchange earning. Sufficient production will also boost shrimp export potential. It indicates that Pakistan coastal region is reliable for the shrimp farming. Previously, many influence steps have been taken for the best use of this great opportunity. Thank you.
Thanks a lot for your presentation, Dr. Rashida Khari. So, yeah, do we have any questions? Anyone of you have any questions? I guess there are no questions. So, yeah, thanks a lot for your presentation. And finally, we are left out with the presentation of Dr. Vincent. Dr. Vincent, are you available? So can we hear you now? No. Like as suggested, could you actually download? Did you download the mobile app? Dr. Vincent, I have received your PowerPoint presentation. Uh, yeah, it's the same, whatever I've received it. But it's only that your voice is not audible to us. So, didn't the mobile app work out? Mm, what do we do now? Okay. Dr. Vincent, it's actually no need to sign in over there. You will just, once you open the mobile app, you will have a box stating enter meeting ID or name. In that place, just enter this number 523078037 and just click on join.
Jessica, he's
Yeah,
chatting in the chat box,
yeah,
and he just said
I've
that you read it.
I've seen. Yeah, I just read it. I'm just seeing what I can
Okay.
do. Like, I'm just trying to
Yeah.
help out, but I'm not having any options. So
Yeah,
I'm
I
just
understand.
what I
I don't
could
know,
do. Yeah, like
but I think the meeting doesn't have a password, so I don't understand why why
Dr.
the
yeah,
message.
Vincent,
I don't.
here.
Ah,
I don't know if you can see, but here.
Yeah, it's clear. Thank you. Thank you for helping.
You're welcome.
so Mr. Vincent, if you downloaded the app, you just need to join the meeting from the app, like in your phone, so we can see the presentation from your computer, and we this way we can hear you. But I don't know if it is not working. Normally, I don't think it needs a password.
Yeah,
You only need the ID.
If you go to check your emails in your phone and click directly in the link.
Yeah, you can use the link directly from your phone, or you just you can type the code or the ID in the meeting app, in the Go to meeting app in your phone.
yeah. Over there, like you will just have to type the numbers. Like I'm not sure if there are numbers or some words. I'm not sure. It's not clear. But could you please try just typing the numbers 523078037 without signing in?
Cette conférence va maintenant être enregistrée.
I think it's working, isn't it?
Yeah, even I tried to log in and it was working.
Okay. Mr. Vincent, can you speak? Is the problem always there? Okay, we can't hear you.
Yeah. Or
Okay, it's logging in. All right.
sorry. I'm really sorry for all the inconvenience.
No,
It's okay.
it's okay.
Okay.
Temporarily available.
Okay.
Yeah.
Okay, I got it. I understand. We got it. Dr. Vincent, so maybe I could suggest you something. Could you please record your presentation and send it us online? We will circulate it among all our speakers. So yeah, maybe we can do this because we are unable to listen to you. And I understand. I'm really sorry for this. I do not know why or like what has happened to this, but yeah, definitely please do take your time to record a video presentation and please send the recording to us. And yeah, we'll be uploading it and we'll send the link to all our speakers.
Yeah, Jessica, Dr. Salah speaking. It's a good way. It's the right way.
Yeah, thanks a lot. Okay, thank you. Thanks a lot. And yeah, I'm sorry for all the inconvenience. So yeah, with this, I guess we have completed a 2 day session of Aquaculture and Fisheries webinar. And I'm really thankful for each and everyone who have participated. And yeah, and we really hope to see you all in our next future conferences or webinars, whatever might come along. And yeah, it was really nice spending time, 2 days of time with you all, and
Hmm.
with all the very good presentations and very informative talks. And yeah, thanks a lot for all of your
Thank
time.
you.
And I hope you have learned something, like whatever. Yeah, I hope you have learned everything.
Yeah, thank you, Jessica, and we are very eager for your next conference.
Yes,
We are
thank
eager
you
for
all.
Sure,
Thank you.
definitely.
Nice.
Yeah,
It was
and
nice to meet you and spend this time with you.
thanks a lot. And yeah,
Thank
definitely,
you all.
maybe. Thank you. So
Thank you.
yeah, once all this pandemic ends, and we really hope we all meet, maybe in a conference, somewhere once everything settles down, and yeah, at a
Yeah.
very safe place. And we welcome you
Mhm.
each and everyone to attend it, so that we can meet once, and yeah, to share each and every idea. And yeah,
Okay.
thanks a
that's
lot, and
Thank
we
you so
really
much.
hope to get your feedback, if there's anything that we can improve from our side, or your feedback and your experience along with us, so that it'll be being a newly invent, like we have just started in 2019. And yeah, it'll be really helpful if you could suggest us any of the things that we could improve, and also your good thoughts, so that we can pen down in our testimonials at our conference website.
All
Thanks a
right.
lot. And
Thank you. Thank you so much.
Jessica, we will be able to get our certificate within this week only.
yeah, within today, we'll send that to you by today.
Yeah, by mail.
Yeah, by email. Yeah, we'll do that. A soft copy of your certificate will be sent to you by email, right? Maybe in 30 minutes.
Yeah. Thank you, Jessica. Thank you.
Thanks a lot. So if there's anything you would like to know from me, please do let me know, so that I'll able to answer them.
Yeah, just let if it is possible, then let us know to all us about your next conference, and we are eagerly waiting for that conference also.
Definitely, yeah, we'll definitely let you know the next conference once it is scheduled. Like, as today, just today we have completed this. Yeah, we'll be doing that by tomorrow or day after tomorrow, and we'll get back to you with the dates, new dates, for sure.
Okay.
Yeah.
Okay.
Thank you,
Thank you.
Jessica.
Thank you very much.
Thank you. Thanks a lot, Dr. Vincent. Yeah. But I'm really sorry. I didn't know like what has happened, and I couldn't help you out with this. I'm really sorry.
So, Dr.
That's so
Vincent,
nice.
we have your
Oh, I guess Dr. Vincent has left.
it's okay.
Yeah.
Okay, so I think it's time to leave. Thank you
Yeah.
to
Thank
everyone.
you.
Thank you, Jessica. See you
Thank
maybe
you.
in the
Bye-bye.
next webinar.
Yeah,
Okay.
sure. Sure.
Thank you so much.
Thank you. Have a great
Goodbye.
day.
Goodbye, everyone. Thank you, everyone.
Goodbye.
Goodbye, Jessica. Goodbye to everyone. I'm Dr. Salves Kadvi from India.
Yeah. Bye bye, Dr. Shailesh. Yeah.